Hello, this is the solution to number 19 in chapter 3 of college physics. So a piano has been pushed to the top of the ramp at the back of a moving van. Actually, it's a moving van, as in for moving. It's not actually moving itself. The workers think it's safe, but they walk away. When they walk away, it begins to roll down the ramp. If the back of the truck is 1 meter above the ground and the ramp is inclined at 20 degrees, how much time do the workers have to get to the piano before it reaches the bottom of the ramp? Alright, so we're looking for time to the bottom of the ramp. That's going to be our delta t, one of the things we don't know. We're also probably going to need the length of the ramp to figure out the time, so you might want to put that in there. There might be a way around that, but for now we probably have to know how far down it has to go. We're also going to say that delta y is the distance from the top of the ramp to the ground, this leg right here. That's our delta y. And then we're going to make an assumption here that the initial velocity is 0. It wasn't mentioned in the problem, but it did say that they left it thinking it was safe. So it's safe to assume that it wasn't moving when they left it. And then we have this component of acceleration we're probably going to need, and we have everything there for it, so we put this equation in there just to earmark that that's going to be a step. We also know that the angle is 20 degrees off the ground. So let's get started. In order to find the delta t, which is our ultimate goal, we have a couple of things that we're going to need to gather from the information that we already have. First off, in order to figure out how fast something's going to be going or how long it's going to take, you're going to need to figure out the acceleration. Most of all these problems are going to have acceleration involved, so you want to be looking for that. So that'll be one of the first things we do. Then we're going to look at the length of the ramp, again using trigonometry. And finally, we're going to talk about how to get the final answer, right? With those two pieces of information, we can use the kinematics equation to solve the problem. So let's get the acceleration first. So here, the next step should be to draw the picture. Before we even talk about the strategy, I should have shown you this. This is where your strategy comes from. So once you get your knowns and unknowns table, draw a picture. There's no way to do a trigonometry problem without it. So always draw it. Alright, so you're going to have to show your work on the AP exam. I wouldn't recommend drawing a picture of the truck, but you should clearly label everything, all the information, both for you in terms of getting it done correctly and quickly, but in terms of communicating also what you're doing, because you might be able to clarify things. It is part of the partial credit aspect of the test, so make sure you do that. So there's the angle underneath the ramp, which is 20 degrees. We have that delta y, which is 1 meter. And we have this length r, which is just the ramp, the length of the ramp in this angled position. And then I also marked the acceleration, which is one of those things we're looking for right now, just to visualize it. Alright, so let's go back to getting the acceleration. So we know from this triangle that the acceleration is going to be a component of gravity, but not the entire thing. So you draw your picture of a triangle so that this line is parallel to this line. And when you do that, this is a right triangle, so it has to be perpendicular to this line, and that makes this line also parallel. Then that makes this angle here 20 degrees, and this angle here also 20 degrees. And with that, then you can start to understand why when you use this, you're going to get this component right here, and that is the sine of that, which is gravity. So gravity is pulling it down, and the ramp is breaking that up into partly gravity, acceleration of gravity into the surface of the ramp, luckily, so it stays on the ramp, and then a downward vector component that's been diverted by the ramp in more of a horizontal direction. And so to get that, we just multiply g, the acceleration of gravity, times sine, times that theta, which in this case is 20 degrees, or let me see, yeah, 20 degrees. So I have that calculation here. We substitute in, don't forget the negative, right? Also, something I forgot, make sure you include your sign conventions. Alright, we multiply it by sine 20, just calculate it. Don't expect you to know that. You just use your calculator, make sure you know how to use the sine, cosine, and tangent functions, along with the inverse. If you do the homework, which you have all been doing, you shouldn't have a problem with that, but you should get used to using it. Make sure you know how to use your TI-84 or whatever graphing calculator you personally have purchased. Alright, so then our answer is negative 3.36 meters per second squared. Then number 2, we're going to calculate the length of the ramp. How far is this piano going to go? And so we had to set this one up a little bit backwards. In this case, we're going to do the length of the ramp times sine theta, and that's going to be equal to this side right here. In this case, it's the 1 meter, or we could say it's the delta y that we assigned. So we plug those in, substitute, and if you're wondering where that came from, it uses the same exact trigonometric function to break up the length. So this length here is the sine of that angle. So you can use it for that as well. So then you just plug and play, get that number, make sure you have that negative, right? That negative means it's going down that way. Down the ramp, the left of the ramp. You can even see it kind of like this. Another system, but we're not going to do that. Another coordinate system. Finally, so these problems get kind of long, so don't forget what your ultimate goal is. Here it is to find time. So the time to travel, we got this distance right here, the length from the second step. We also know that the acceleration is 3.36 and it's negative. So we have all we need to use this equation. Basically one of the kinematic equations, the one that's a quadratic normally. We think through the problem. We know that the initial velocity is 0, so this term drops out. That gets rid of this quadratic idea. Now we are able to just get away with just square rooting. We solve or rearrange for t, getting the unknown on the left and all the work on the right. And then we substitute in, including our units, making sure we keep the negatives. These tend to cancel out underneath. So if you end up with a problem where they're not canceling, double check that you did all your work right, because a lot of times that cancels. It hasn't been a problem. You don't usually get imaginary numbers in these situations. Alright, and then time is 1.32 seconds, which is, hopefully they see it and they're not too far, but it isn't really a lot of time for them to save an entire piano from crashing down at the bottom of the ramp. Thank you. This concludes our solution for Chapter 3, number 19.